decisive indecision there. All right, the recording has started. Nicholas, I'm going to turn it over to you to go ahead and introduce yourself. Thank you very much.
Thanks, Steve. Thanks for setting this up and for inviting me. And to everyone who's listening today, thank you so much for joining the talk. My name is Nicholas Barretta. I am a Zero Trust Global Black Belt here at Microsoft. So my role, if you ever worked with anyone on the Global Black Belt team here at Microsoft, basically our role is to work with customers and engage really deeply in certain areas around solutioning and strategy in the cloud. So for me, my area is specifically around designing for Zero Trust and building and implementing Zero Trust models in large cloud and multi-cloud environments. So the reason you're seeing Cloud Knox all over the graphics today is because I recently joined Microsoft via its acquisition of Cloud Knox a couple of months ago. This is not a Cloud Knox sales presentation. This is not going to be a presentation that is focused on the Cloud Knox solution. Rather, it's going to focus on the space we operate in, which Gartner calls CIEM, Cloud Infrastructure Entitlement Management. I'm going to talk a little bit about what that is, why it's getting focused from customers, and how organizations, what problems and what challenges organizations are looking to this space to solve in their environments. There's going to be a high-level look at the problems with access control and the current challenges with access control in cloud today, specifically around getting to a zero trust model and staying there. And then I'm going to talk a bit about what a complete CIEM solution should have if you're going to look down that path to try and address and mitigate some of those challenges. My presentation itself is not going to be the full hour, so we will have ample time at the end for Q&A and discussion. So I encourage you to think of questions and be ready to ask them when the time comes, okay? So what we're going to talk about today, the current challenge, what is the actual problem with cloud access management? Why does access control become an exponentially larger challenge in a cloud environment? How does a complete CIEM solution help solve that problem? And then some example use cases. There isn't going to be a demo component. I just forgot to take that off the slide. If anyone's interested in seeing a demo of Cloud Knox as an example of a CIEM during the Q&A, I can pull it up, or we can connect offline if you want to talk further about Cloud Knox specifically, okay? So let's start by framing the problem statement. So the inaugural Gartner CIEM report, which they released last year, July 2020, said that by 2023, 75% of security failures are going to result from inadequate management of identities, access, and privileges, and that's up from 50% in 2020. And I can say firsthand, prior to joining Microsoft, prior to joining Cloud Knox, I was a solutions architect at AWS for 2 years. I was a customer engineer at Google Cloud for 2 years before that. So I know from firsthand experience working with customers who are building their foundational cloud environments, their foundational cloud center of excellence, those types of teams, those types of processes, that this is something that is a major challenge, access control in the cloud. And like I said, this is trending upward. It's up from 50% in 2020. And I've got a couple of examples. If you look at the major breaches, as in major being the ones that have ended up in the news over the past 3, 4, 5 years, you can really see that the vast majority of them relate to an attacker getting a hold of an overly permissive identity. So I'm going to go through those in detail. Before I get to that, let's just frame let's define access management, what we're using as our reference for that term. So in general, you've got an identity, could be a human identity, could be a machine identity. You've got a resource that identity is trying to take some action upon. This has been true long before cloud came into the picture. Back in the days of on-premises data centers, you'd have people who had credentials to access. So for example, your infrastructure team could access your vCenter environment. Your storage team could access your SAN and your NAS. Your networking team could access all your networking equipment. And they all had credentials that would give them access to those resources. And in situations where they had to deal with an escalation or deal with an outage, they would have escalation capabilities where maybe I could say I'm on the infrastructure team. I need to escalate to an admin account in vCenter to fix something in vCenter, or I need to escalate to a domain admin account in AD to fix something there. That paradigm hasn't changed as we've moved to cloud, but cloud has exacerbated what we call the permissions gap. And we define the permissions gap as the gap between the number of actions, the number of permissions, the number of things an identity can do versus the number of things it actually has to do or actually does do on a day-to-day basis. And what we find looking at customers' cloud environments when we were doing our initial kind of discovery and initial validation with customers is the vast majority of customers we work with, and that's true if they're on Azure, if they're on GCP, if they're on AWS, if they're on some combination, the vast majority have way more permissions granted than are actually being used on an identity by identity basis. It's around 5% typically. So of the permissions granted to an identity, around 5% are actually used. Why has this happened? Well, in the cloud, you're no longer bounded by physical access to infrastructure. You're no longer bounded by physically being able to access the machine or the storage array or whatever piece of equipment you're trying to fix. Everything is served over the internet via APIs. What that means is if you're granting access to someone like a developer or a user in the environment, an admin, you're basically giving them you're attaching a document to their identity, whether it's an AWS IAM role, an Azure RBAC role, a GCP role, that basically says this identity can do these things, can take these API actions. There are literally tens of thousands of possible options. Azure, AWS, and GCP alone all individually have, Azure and AWS definitely have north of 10,000 API actions. GCP has north of 5,000. And then you add in VMware as well, it's another couple thousand. There are thousands of types of resources that you could access, and there are an infinite universe of permutations of combinations of identity, access, and resource that you could generate in terms of any one policy document or role definition. So as far as getting to zero trust and least privilege, basically the way organizations are doing it today is it's a very manual problem. They're throwing a lot of manual effort, and they're throwing their security teams, their IAM admin teams at trying to craft and maintain right-sized least privilege policies or role definitions for every identity in the environment. With the scale at which the cloud environment is growing and the scale at which the providers are adding new APIs, new services every day, it becomes, quite frankly, impossible for them to maintain least privilege policies, least privilege role definitions manually on an ongoing basis. So what does this lead to? It leads to something that we call just-in-case permissioning. And you may have never heard that term before, but you might intuitively understand what it means. I don't have time to craft a bespoke policy, least privilege role for every identity in my environment. And so what I'm going to do is I'm just going to, figure out the best possible one-size-fits-all approach. I'm not going to give you everything, but I'll give you enough that you can do your job while not burying me with, spending my entire day, every week, managing and maintaining policy and role documents. So I'll get to that in a moment. What I want to talk about first here is a couple of recent attack chains. Both of these they just happen to be AWS examples. They're not specific to AWS. This attack pattern, this problem is not specific or emblematic to AWS or any one particular cloud provider. I do want to say that. So this is a recent attack chain. Actually, this happened in, I want to say 2 years ago, maybe last year. COVID has kind of warped my sense of time a little bit. This was a major financial services institution that actually, was compromised and ended up in the news, pretty high profile thing. So in this situation, an attacker was able to gain access to a running, in this case, EC2 instance in AWS. And that instance had a identity attached to it. It had in this case, an AWS instance role. All of the cloud providers, AWS, GCP, and Azure, they give you the ability to assign identities to machines or assign identities to services to allow those services to interact with cloud APIs. So in this case, this instance had to do something with another AWS service that involved it needing to read and write data to a particular Amazon S3 bucket. However, because the policy that was attached to this IAM role was overly permissive, it didn't just give access to the one bucket that that role needed. It gave it access to every bucket in the environment, every S3 bucket, which some of them had customer records, some of them had sensitive data. And so what happened was the attacker basically got in, they were able to take advantage of a misconfiguration to get access to this instance. Once they were on the instance, it was trivial for them to get access to these credentials. And the reason for that is because if you're executing on the instance itself, if you're running a script on the instance, or if you're running in a shell SSH terminal connected to the instance, getting the credentials that are attached to it is as trivial as just making a call to the instance metadata server. and there's no authentication, there's no check that happens by default when you hit that. So the attacker, once they were on here, was able to get the credentials, and then it was very simple discovery to see where they can move laterally. And in this case, they were able to discover and exfiltrate over 100 million customer records. And that is the piece that got this breach on the news. So a couple things happened in this attack chain. Obviously, there was a misconfigured firewall, and that's a configuration management problem. This attack could have stopped here if this role was sized for least privilege, but it wasn't. It wasn't because of the myriad challenges I talked about with actually managing and maintaining least privilege at scale in a large cloud environment. So in this case, that configuration error, it turned into something that ended up on the news, very visible in a very visible manner. The second incident, similar. Again, attacker was able to get onto a misconfigured AWS instance that gave them access to connect to it, poke around, see what was in the file system. And there was actually an API key that was exposed. So API keys are used in lieu of machine identities. You can also generate credentials and generate API keys that you can then store as environment variables and call them to interact with APIs through your applications running on an instance or running in a serverless environment. So basically, the attacker got in, was able to get this API key. That API key was associated with an identity that was overly permissive. In this case, the identity had the ability to access all of the database snapshots that had been taken for the production database of this customer. This customer is a software as a service firewall provider. So in this case, the attacker was able to restore the database from snapshot. That database had all of the user accounts and password hashes, as well as certificates and private keys for over 13,000 customers of this provider. So that was really bad because that basically meant the attacker could compromise those customers' networks if they were to use those keys, use those credentials. So two attack chains that are pretty similar. And again, not picking on AWS specifically. This is just kind of general cloud. The types of breaches we see in the cloud fall into two buckets. Generally, the one bucket is configuration mismanagement. That would be something like, someone puts data into a blob storage container that has anonymous access turned on, that it shouldn't be in that container, or someone puts data in a public S3 bucket that shouldn't be there. Those are configuration management issues. And we as an industry, we're not perfect, but we are getting a lot better at managing those through infrastructure as code, through different tools and services that help enforce configuration, both native cloud provider tools like AWS Config as an example, to third-party tools like Cloud Custodian that let you manage and monitor configuration as code in your environment. So we're getting better at managing configuration management, but configuration management isn't perfect. Misconfigurations ultimately led to these instances with these credentials being compromised. The other bucket of breaches is an attacker getting a hold of overly permissive credentials. And it's going to continue to be a problem until we as an industry are able to come up with a better solution for managing and enforcing least privilege and getting to zero trust for identities in the cloud. And so that is the genesis of why CIEM exists. It's why Knox exists. It's why companies like Microsoft make acquisitions in this space. That's why we were acquired. So there is a focus on improving this area for all customers in the space. And this is a quote, this is actually a quote from Steven Schmidt, who came out after that high profile breach and made the statement. Even if you misconfigure a resource, if the customer properly implements a least privilege policy, there is relatively little an attacker has access to once they are authenticated. So the takeaway here is a layered defense model. Identity is a critical layer. So you have to make sure that you are generating policies that are only granting the access that is needed and nothing else. And in order to do that, you need tools that enable you to take a data-driven approach to policy generation. And what I mean by that is just a slide illustrating the permissions gap I talked about. I'm going to skip it because I did summarize it a bit earlier. I tend to do that a lot. I tend to steal my own thunder. I'll talk about something that's coming in a slide, 2 slides from now. But what I mean by tools that help you address the root cause and tools that help you take a data-driven approach, there's 3 root causes that ultimately lead to the permissions gap. The one is there's a lack of visibility. So in general, the customers I've worked with pre-Cloud Knox and even at Cloud Knox when we were first getting engaged, what they tell me is they don't have any visibility into what access exists in their environment. And what I mean by that is they can go into, say, Azure AD, and they can see which Azure RBAC roles are mapped to which users, which identities, or maybe they can see in AWS which users and roles and groups exist and which policies are attached. They don't have any visibility out of the box to see which of those permissions are actually being used by those identities, what permissions are assigned, which are actually being used, what resources can be accessed with those permissions, how can these identities move laterally. So this is particularly a challenge in AWS where you have cross-account role assumption, and you have things like, a user can assume a role and then assume another role and then daisy chain those together to move laterally in the environment. Getting visibility to that is really, really difficult. The second piece is role engineering itself is just really manual, permissions engineering. So creating and maintaining policies, like I said, is a manual process. Anyone on the call who's done this or whose job is to do this or maintain this, you can probably sympathize with that. You could spend all day trying to maintain all of the policies and all of the role definitions for the entire organization to get to and stay on least privilege, and to be your full-time job, and you still probably wouldn't be able to keep up with just the volume of data. And the third piece is just in case access, which is because of these challenges, because there's a lack of visibility, because there's this manual effort in maintaining bespoke roles and bespoke policies, you end up just getting the just in case model. And that model looks like this. This is basically how permissions engineering works today. You've got a developer, an end user. A developer could be, a development team or the manager representing a development team. And then you've got someone who's responsible for being the IAM admin. Could be a centralized IAM admin, a decentralized person crafting policies and roles. But this is basically a negotiation, assumption-driven negotiation that happens when this user is requesting access and this person is responsible for granting that access and generating this definition. So the developer will go in and say, I'm working on this application. I need these 100 permissions to this environment. And the admin will look at that, review that request. This usually involves opening a ticket or, sending an email or making some kind of request. And there will be some back and forth here. The admin will say, okay, well, I'll give you this. I can't give you these. These aren't allowed by policy. There'll be some back and forth. And you'll get one of two models here. On the left side, you might get an admin or an admin team that rotates on the end of lockdown, where they're not going to grant hardly anything that's requested. That might keep the environment secure, but it's really going to stifle the pace of innovation. Developers are going to be able to work. And that's also where you get the proliferation of things like shadow IT, because developers will just work around those kinds of limitations if it's preventing them from doing their job. Most organizations I talk to tend to rotate onto this side, the just in case model, where this admin will say, okay, look, I don't have the bandwidth to handle 500 access requests a day. So what a lot of organizations do is they'll grant kind of one size fits all or t-shirt size policies. We'll say, this is what a developer typically needs. This is what a data analyst typically needs. This is what an infrastructure engineer typically needs. They'll grant those one size fits all policies or roles, and they'll assign them out as needed. And that's where you get to the permissions gap, because those policies, while they're building them bespoke to that role definition, what their idea of that role needs, they're not actually least privilege. The only way to really get to least privilege is to take an individualized look at what users or even small teams are doing, and then continuously revoke the access that they're not using on an ongoing basis. That is really the only way to get there. But the tooling out of the box today doesn't really offer that kind of capability without some big heavy lifting required on the customer side. So if we get to the solution, what does a complete CIEM need? And I did say I'm pretty close to nearing the end of my talk track here, so I really like this to be a discussion at the end. So we're gonna have a lot of time for Q&A and just to answer questions. But what does a complete CIEM solution need to address this problem? And the first thing you need to address is you need to address the visibility gap. So you need to have a platform where admins can log in and see not only what identities exist, but what permissions are attached to them. How do they get those permissions? Is it direct attachment, group attachment? Are they inheriting them somehow? And of those permissions, what are they actually using versus what's been granted? And this view has to be consistent across all the providers. So for example, in Cloud Knox, there's a risk metric called the privilege creep index. It goes from 1 to 100. The more unused high-risk permissions an identity has, whether it's a human or machine identity, the higher that risk index is going to be. So if you have 100, that means you basically have admin access and you're using none of it. over the past 90-day period, let's say. So that's really important to have that kind of visibility, because that's going to arm you with the data you need to actually make data-driven decisions and do some automation around least privilege access management. Once you have the visibility, the next piece is remediation. So remediation can be either automated remediation or single click within, web console, web interface. But remediation means going through and continuously identifying and revoking unused privileges from your identities in the environment. So basically vacuuming out all of the unused high-risk permissions that might be attached to identities. And there's multiple ways to do this. It's really important. You see this bar at the bottom, API for integrations. It's really important that your CIEM has a complete API. I've seen customers do things. I'm going to talk about some of the use cases I've seen. But for example, the API would allow you to do things like within a Terraform module or within a deployment pipeline, make a call to your CIEM and say, hey, here's an identity. I want to get a right-sized policy for this identity based on their activity here. And then provision that access here. So I want to get their activity in dev, let's say, and then provision least privilege access in staging as I step through my deployment pipeline, as one example. So it's really important that this can be automated and integrated with your existing options. And then the third piece is fine-grained. JIT stands for just-in-time access. So it's one thing if you're talking about access control, it's one thing to take permissions away. But if you only take things away and you don't give developers, you don't give end users a way to quickly escalate their permissions, you're just going to get the permissions gap occurring again, because it'll eventually just recur over time. Permissions will get taken away. Developers will make noise that they need more access. And eventually, one of two things will happen. They'll just work around the limited access they have, shadow IT, or the permissions gap will start to creep back in because they'll start seeing admins granting more access just to enable them to do what they're saying they need to do. At the same time, the current privilege access management, the current privilege escalation paradigm that exists, if you're out there and you're using a CyberArk or a Thycotic or those kinds of tools, I might have a read-only access to a prod Azure subscription typically, but maybe I need to escalate that. Maybe I need to deal with a production issue. Typically what a customer will do is they'll take an editor or contributor or owner level role, they'll put it in CyberArk or Thycotic or the like, and then your user will go check that identity out of your PAM tool when they need it. That'll satisfy the privilege escalation use case, but it won't do it in a way that's congruent with least privilege zero trust, because you're granting someone broad access to the environment to deal with a very targeted escalation use case. And it's less likely that the person requesting the escalation is going to be malicious with those credentials, although it's certainly possible to have an insider. What is much more common is someone dealing with a pressure situation like an escalation, fat fingering something, making a mistake, or accidentally deleting something that they wouldn't have been able to delete if they weren't using such a broad access credential to deal with the escalation. So your CIEM should have a mechanism for granting just-in-time access at a fine-grained level. And what that means is rather than vending out a separate credential, rather than vending out admin access for 2 hours, attach an ephemeral policy or an ephemeral role to the principal identity making the request. So if you need 5 permissions, the CIEM will attach those 5 permissions to your identity for 2 hours and then take them away when you're finished, when your time's up for that request. If you requested for 2 hours, if you requested for 2 hours on a recurring basis every Monday, the tool should automatically manage that granting and revoking that access in a fine-grained manner. It should support all the same approval flows, self-approval, automated approval, management approval that you get with your existing PAM tools integrated with your existing ITSMs, but it's really important that it's fine-grained. What this will do, the remediation controls and the fine-grained access controls together will create the basis around which an organization can begin to adapt its access control policies. Where instead of having to maintain those broad access roles, instead of having to do just in case permissioning, they can grant just what is needed, build automated remediation tools and automated remediation guardrails to automatically remove on an ongoing basis the permissions that aren't being used, and then also offer just-in-time access for escalating privileges that maybe aren't needed on an everyday basis, but are needed maybe once every 6 months or ad hoc as escalation scenarios come up. So that's how you go back to users who say, you can't take those permissions away because I might need them some way. Well, might need them someday. Well, if you need them someday, use just-in-time access to request them as needed. So that is the model we see our customers skating towards with tools like ours. And then the use cases, so being able to detect and disable inactive identities in groups is one. So there is a huge proliferation of roles, of identities, of machine identities, service accounts, Azure App Service Principals that are actually just inactive, that are sitting there with access, but are not being used. So the tool should be able to detect and delete those immediately and continuously detect and delete those. Removing all high-risk permissions that haven't been used over 90 days, over a trailing 90-day period. If you haven't touched a permission in 90 days, you don't need it to do your everyday job. You might need it sometimes, and that's where fine-grained privilege on demand comes in. Guardrails to continuously monitor and enforce least privilege based on activity. So if I have a metric, if I have a risk score that says, okay, this identity has a risk score of 80 based on its permissions granted versus what it's actually using, well, I can use that as the basis for remediation. You can't improve what you can't measure. The corollary to that is if you can measure it, then you can improve it. So what that means is I could build an automation that says, hey, for every identity in this Azure subscription or every identity I have in Azure AD, look up its risk score, look up its privilege creep index. Anything above this threshold, let's say 20, anything above 20, automatically right size it. Generate the least privilege policy and attach it to this identity. Generate the least privilege role definition and attach it. So that is a pattern many of our customers begin to adopt once they become more mature with how they're using their CIAM tools generally. Customers tend to start tactically. They tend to start by using their tools to identify the highest risk areas and remediate them on a one-by-one basis. Once they've addressed the low-hanging fruit, that's where they want to start adapting some process change around the tool. I mentioned automated access control as part of your DevOps process. The vast majority of customers that I talk to, they have a model where they deploy to dev first, and then they deploy to a series of non-production environments, and then they eventually deploy to prod. If you think of that as a spectrum where dev, you've got broad access because your dev environment should be isolated, should be completely sandboxed from production and even non-prod. If you think about that spectrum from broad access going to prod, where you might have read-only access if you have any at all, well, you can automate access control as part of your DevOps pipeline. So I alluded to this earlier, but let's say Dev Sandbox, I've got my development team building in there. I'm recording their activity with my CIM as they're building. Once they're ready to deploy to staging, once they commit their code, commit their infrastructure as code templates to the repo and kick off the deployment to staging or to non-prod, I can have as part of my build job a step that goes out, hits the API of my CIAM, gets that least privilege policy for their activity in dev, and then generates counterpart access controls in the non-prod environment. Basically provisions them with least privilege access based on their activity in a zero-touch manner, zero touch and zero trust. So that is something they see customers starting to move towards as well. And then all of these are really meant to be kind of preventative controls. But you also want monitoring. You want to be able to monitor anomalous behavior. You want to be able to see if an identity is using permissions in a way it's never used them before, or is suddenly doing things that are anomalous with its activity patterns. If the tool has that built in, that's a really nice value add as well, because then you can, in addition to the preventative controls, you can build a layer of detective controls, see if there's any gaps in your analysis, any gaps in the permissions you're monitoring, things like that. And then the last use case I mentioned is that just-in-time fine-grained access. So going back to kind of tying these two use cases together, once I get to production in my pipeline, I might create the role, the least privilege role or least privilege policy, but not attach it to anyone. So you get read-only access, but I'll create this unattached role, and then you can use that role as the basis for your privilege on demand. So if there's a problem with your application in prod, now instead of you having to go get admin credentials from your PAM tool, you can go in and request, hey, I need this application specific policy that I know is right sized because it was generated as part of this DevOps pipeline based on my activity in the earlier stages. So all of these use cases do kind of intermingle to enable customers to fundamentally change their policies and procedures around access control to make them more scalable and more aligned with zero trust and least privilege end to end. So I talked a lot, but I don't really, personally, I prefer to have conversations versus just kind of coming in with slides over the head. And again, I'm not here to talk to you about Knox specifically or Microsoft products specifically. I'm just here to kind of share some of the things I've seen, experiences I've had with customers, even dating back to my time pre-Knox, and what sorts of challenges these access control presents and how customers are using tools in the CIAM space to address them. So with that being said, we've got plenty of time, and I'd love to open it up to some Q&A and just have a discussion.
Hey, there was one question from Christopher. I kind of answered it in the chat, but it says if approval of just-in-time access is automatic or self-approved, what stops an attacker from getting the access?
Yeah, it doesn't have to be automatic or self-approved. It's more about thresholds for different types of requests. An organization might decide that a particular request, say a request to access one particular bucket that doesn't contain sensitive data, or one particular container doesn't contain sensitive data, that might be a request that meets the threshold for self-approval or auto-approval. Other requests, particularly requests that would involve accessing customer data or accessing data that would be subject to, or resources that are subject to data controls, governance controls in the organization, that would require some level of approval, from direct manager approval, potentially all the way up to VP approval and or security team approval. So it's not so much that every request should be auto approved. It's more that you should have the controls to build the approval flows that are dictated by the security posture of the company for that particular resource or data. Does that make sense?
It does to me. I also answered it with in another way, saying that things like MFA and conditional access, location-based access or coming from managed device could be put into that workflow, so that if somebody's coming from a managed device and they're trying to access something, then they can self-approve. But if they're coming from outside, then they need to verify other ways.
Yep, that's also a good point. I can't see the chat right now, so I'm just curious if there's any other questions that came in or anything else anyone's curious about.
So Brian Arkhills writes, Bloodhound help change the paradigm around understanding lateral movement risk, and Defender for Identity has the same features set today for AD on-prem. I'm wondering whether Knox has something comparable.
That is something that is actually the number one focus area for us post-acquisition. So right now, Knox, talking about Knox specifically, it covers the API surfaces of the three major cloud providers, GCP, AWS, and Azure. The top line item on our roadmap, I would say, is expanding what we do to Azure AD and Active Directory on-prem to basically take the same kind of analysis we do on access levels and permissions granted versus permissions used and extend that to first AD, but also other systems down the line. The underlying technology that does that access control analysis is actually a patent that Knox owns, that Microsoft now owns. And so the top line item there is taking that and expanding it to other systems as well. So it's the cloud providers today, but in the next year, there's gonna be a lot of exciting stuff coming out.
That's all the questions from chat. Oh, wait, no more. R. Smith writes, question, thoughts on maintaining a separate admin identity for admin functionality even after things like just-in-time or CIM are rolled out. Some feel once above is in place, you should use your daily driver identity for admin functions, ultimately looking for thoughts on where a line should be drawn to accommodate both.
Sure. I've heard this kind of position come back from some customers I've talked to. And really what I've heard when I've dug into it is like, well, if you had just-in-case access and just-in-time access, why do you still feel the need to maintain a broad admin credential? And one of the most common things I heard in response to that was, well, we want to be able to audit who's doing what. And if they're using the admin credential, then we know that we have one kind of identity we have to monitor and see, who got access to it and then what are they doing. So one thing I should have said in my presentation is that it's really important that if your platform offers just-in-time access controls, those are fully logged and audited. So who requested what, on what schedule, who approved it and why, or who rejected it and why, and then when has it been put in place. So I shouldn't assume it goes without saying. So I'll say explicitly, your just-in-time controls should have that audit trail in place. At the end of the day, every credential you maintain that has broad access, that level of access, you got to think of it as it's increasing your attack surface. And sure, it might be unlikely that it's compromised if you rotate keys every day, if you keep them in a PAM, if you keep them in, under lock and key, if you keep them behind 2FA and you keep the 2FA device in a safe. Those things are all true. Still, it is a surface that you're maintaining unnecessarily, in my opinion. If you have the ability to handle escalations for the principal identity on a fine-grained basis, and you have the ability to audit who requests what, who does what, and see those actions, I think you can satisfy that use case without needing to maintain that broad level of access personally. The other thing I would say to that is, again, it's not just insiders, it's not just malicious actors, it's also, mistakes, fat fingering, things happening that are unintentional but still destructive to the environment. One example I'll have, I'm going to be deliberately vague because I don't want to share any identifying details, but in one of my past lives, I was working with a customer that had they were moving to cloud. So the vast majority of their business's workloads were in the cloud environment. And they had an issue with any customer running in cloud. They'll have their application environments, and they'll usually have like a shared service environment where they'll deploy things like, AD controllers or, different things that are shared across the entire environment, critical infrastructure, deployment pipelines, things like that. Well, I had a customer who was dealing with an issue, escalated their credentials, and in the process of dealing with the escalation, they meant to delete one particular deployment pipeline, and they ended up deleting all of them. And because their credentials that they had escalated to had the ability to do that, nothing stopped them. There was nothing that popped up and said, "Are you sure you want to delete all of your deployment pipelines?" You could argue that's something that the service should have maybe done, but it didn't. And so that situation was particularly painful. It involved us getting some professional services resources engaged for free to go in and help fix that. But it's just one story I've seen of something where that could have been avoided if the escalation credential they were using was more fine-grained to the escalation they were dealing with, because they really didn't have to be able to touch all those pipelines to deal with that one issue with that one pipeline. So long answer there. I hope that helps answer the question. And, obviously they're my thoughts, they're my opinions based on my experience. But that's how I would respond to that.
Sure. Brian, response to this, I think the visualization provided is what is really useful about Bloodhound Defender for identity. So really interested in seeing something comparable for cloud services. That was just a follow-up to that. John Cutler writes, we at Marshall use separate admin and daily drivers. It's easy to disable an admin account when someone leaves the IT department, but may not necessarily leave the university. This kind of, and I'm just adding to this kind of holds true because inside of education, you'll have people that are students and start working, then go back to being a student again. So rather than disabling their account, that kind of does make sense. But may not necessarily leave the university as they continue their roles employee in another division, a student or even alumni. They still keep their daily driver identity.
Yeah. So sorry, was that a comment or I just want to make sure?
I think it was just him saying what he does, what they do at Marshall, which kind of makes sense for a lot of universities because they're going to have people that have multiple roles, move from one role, and when I say role, student, faculty member, and in and out of those roles. So sometimes having the daily, the admin account rather, makes sense in those cases.
Yeah, one thing I'll say too is we tend to sit, tools like ours, we don't typically sit in the provision, deprovision, onboarding, offboarding flow. Customers have their existing IGA tools for that kind of flow. What we do though is we provide an augmented set of data where you can see not just what role they're getting, but that role they were granted, this is the permission they've been given, this is what they're actually using. So it could be useful in also adapting the baseline roles that are given to people in terms of granting that initial access, even for the daily driver. So it also has that kind of value for customers as well.
Christopher Clayton writes, many of us in higher education are operating like Hotel California. You can check out anytime you like, but you can never leave. R. Smith, my biggest argument for separation of admin identity, even after PIM, is the likelihood of primarily being comparative compromised. I agree with you, though, on reducing attack surface auditing, etc. Appreciate the response.
Yeah, no worries.
And there's no other questions in the chat. If anybody does have any questions, please come off mute, ask them now. Caden has already put the link to the survey. Please do fill out the link. We're interested to see what you're thinking about the sessions and how we're doing. And at this point, Nicholas, unless you have anything else, I'm going to go ahead and stop the recording.
Yeah, I'll just say thank you to everyone for the time. I hope it was valuable. I know it's always hard doing these over Zoom because it's hard to see, or over Teams, I should say, because it's hard to it's hard to see the audience reaction in real time. So I hope it was engaging. Hopefully we'll be able to do this in person again at some point in the future. But thanks a lot for your time. I really appreciate it, and I hope you found it interesting and insightful.